to simple show. When it comes to every other project, when you're as a programmer, when you are dealing with any project in your life, when you come to a certain stage in your life where you have to deal with such projects, there is something else you to understand. Okay, we just don't jump into a project and start solving it, like because that's what the task is asking you to do. There is always ways, or what should I use? There are ways you have to always attend to projects. Okay, and then one of them is, one person said something like, in order to be able to, when you are about to go to fight, okay, with an opponent, in order for you to be able to win or conquer them, you have to know some things about them. Okay, you need to know, like, let's say if you're a boxer or a wrestler, you're going to wrestle with someone else. You need to know some things like their wins, their losses, their height, their weight. There are a lot of things. You need to know their background. It gives you the upper hand. Okay. That is how important information is to a programmer or a software engineer. You need to have the basic information or the basic idea about that particular project. So when you wake up and then the project or the task is there, the first thing you do is you have to search or do background research about it. So let me save you the trouble of that. Before that, does anyone know what a simple shove is? Let's start. Let me choose my pen from here. Let me zoom out. Does anyone know what a simple shove is? Can anyone help us with what a simple shove is? What is a simple shove? Anyone will tell you what's a shove? What just happened?
Hello.
Yes, sure.
I hope everybody can hear me.
Yeah.
According to me, I think a shell is an interface where we type in commands,
Mm-hmm.
and then these commands are translated. Uh,
That is true.
they're translated and executed
Okay.
by the operating system.
Okay. 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 Thank you, Shema. Is an interface, right? Wow. Wow. So simple. Sure. Right. He said it's an interface. I want us to get that down. And please, if you are having your notepads around, please write down that down first. He said something, so we have one. Wow. Okay, so one is an interface. Okay, so he said something. It executes commands, right? Shem, please, am I right? He said it executes commands, right?
Yes, yes.
Yes, it executes commands, right? Good. So shell, we first know that shell is an interface. We know that it executes commands. Does anyone want to add anything to it before I start? Admit. Oh, sorry about that, guys. Please, when you have something to say, please just unmute yourself and talk. When you're done, then you mute yourself again. Yes, because I want to see when you raise your hands. It will just confuse me. So please, anyone else, you can just talk.
Okay, for me, I would say that shell is just like a bridge between the users and operating system.
It's a
Shell
bridge.
itself is a command.
Okay.
We need something for the user and operating system to interact. So that shell is like a command that the user will type in and the operating system will understand it and give out outputs to the user.
Okay. So it's a bridge between the user and the operating system. Anything else? Thank you very much. Anything else? Um, anyone? Shall I move on? Thank you very much. Yes, it's a bridge between the user and the operating system. That's a very nice analogy. Anyone else? Okay, not to waste much time. Let's move on. So I would like to have this on a different yes. So first of all, I want us to know something about the history. Okay, let me use let me remove this thing from my pad so this writing becomes smooth. Okay, so I want us to understand something. The history of show. So, as I said earlier, you need to gather the most anything you can get about it, the definition, the history, how it came about, everything. And from my research, okay, let's say in the early days of computing, okay, in the 1960s, this thing is really going to worry. In the 1950s and the 1960s, in the early days of programming when computer was new in the system, this is what happened. Okay, computer was mostly large. When we say computer, it's not these days and portable and then accessible devices we're having. It was a very large and then expensive what medium to come about with, right? It was very expensive to even get your hands on a computer. So I'm trying to explain how Shell came about and how Shell was built, or the ideology behind Shell. So let's say in the 1950s and then the 60s, okay. So if you're a programmer, let me use today's wording. If you're a programmer, let me mention them. Like let's say Shem, you want to your a computer to accomplish a certain task for you. Okay, this is what happens. In those days, this is what you do. You take pencil or whatever you can use to write. You write your commands, you write your tags, and then this is what happens. So it's like you find the computer operator, and the computer operator was the one with access to the computer. All right. So it's like the whole country. No, let me not use country, but that's the ideology. Like, let's say the whole town can have one computer, and we have the computer operator. And the computer operator is the person who is going to take all these tasks from who? Shem, and then he's going to operate it into the computer and then tell the computer this is what Shem wants you to do. And that's what happens. So after the operator runs the command and everything, at the end of the day, everyone gets their output. So let's say if Shem wanted to do a simple thing, like let's say you wanted the computer to do a task like, let's say you needed to add 1 plus 1, okay, 1 plus 2, sorry. And we all know that 1 plus 2 is what? 3. That is 1 plus 2 is 3. It's a very simple thing. So let's say for that time, no one knows what 1 plus 2 is. And Shem wants to know what 1 plus 2 is. So what he does is he writes what? The 1 plus 2 and sends it to the what? The computer operator. So let's say it was should I how should I explain? It was, let me use this analogy. It was between two walls, okay. So it was between the computer and what? And the user, or Shem, the user who wants to what? The computer to perform the task. And this line in between here was the person who was responsible, or known as the computer operator. The person was responsible for what? Letting the user see their results and everything. I think I have to hide this tax bar, but you can ignore it. Doesn't bother people. Is anyone bothered by the fact that this tax is always showing? Let me ignore it and let's move on. So let's say, so if user one, okay, which is Shem, goes and be like, I want to know the results of 2 plus 2. So this line between here is a bridge, as our sister said, is a bridge. This is what prevents the user from directly asking the computer what is 2 plus 2. So in order for you to know what 2 plus 2, so in order for Shem to know what 2 plus 2 is, Shem has to go through this line, this bridge, and that person was what? The computer operator. So that was what was happening. So let me accept this person, admit to, yes, good to go. This is really going to be trouble. Please, as I said, you need to help us the next time how we are going to be able to accept people. So the computer operator is the person going to what? Ask the computer directly. He's the one with access to what? The complexities, the algorithm, everything about the computer. So you, the user, you don't have direct access to the computer. It is the what? The computer operator that was doing this what? This job. And when it finishes running and say, okay, so Shem, your answer is 4. At the end of the day, the person in between, the bridge here, the computer operator, let me find a way to write it. Let me just say CO. So the computer operator has to find a way. At the end of the day, he is the one who will communicate it back to the user. And he's going to tell the user that, Shem, the codes or the program you wrote or the task you asked the computer to do, your answer is 4. So that is what happened in those times. So it was a bit of, I don't know, imagine, let's say you have a whole lot of things to do And then you always have to write all of these things down. And then let's say there are almost about, I don't know, there can be a lot of users in the whole city. There can be a lot of five people with problems they want the computer to solve and have to go through this step and wait at the end of the day to get their output. So imagine imagine something like let's commit an error here. Let's say at that during that time the computer didn't know anything like this exclamation mark, but Shem wants to know what it is. And then the computer operator runs it and then realizes that this thing is not a task that can be performed by the computer. So it's an error. So at the end of the day, you go back and then all you hear is that your task cannot be done because it has this error. Go and fix it. So you have to take off the another day and perform that work and bring it back to the computer operator. So the first time, sadly for us, the first time computer replaced our works for us, not even the first time, but in those days was when around the 1970s, Ken Thompson, that was his name, right? Sorry, let me write it. Ken Thompson came about the idea of shell. So this is what happened. So let's say in around 19, I've forgotten the exact year, but I think yeah, in the year 1970, we had this genius called Ken Thompson. Please bear with my handwriting. I'm using a computer, so even in real life, my handwriting isn't nice. But either ways, so in the 1970s, this is what happened. Ken Thompson brought a solution to this problem. Okay, just like how every other, he worked at Bell Labs, right? Bell Labs, it was a big company. Bell Labs was a big company for such stuff like software, computer, about computer. And then he came up with a solution that instead of someone always being the intermediary, let's go back to the previous note, always being the intermediary to take the what, the tax, and then giving it to computer. How about everyone gets access to the computer and has a way of communicating with the computer? Okay, that was the solution to the problem. And he said, okay, then he came up with what we were, the concept of what shell. So that is what shell means. That is how shell came about. Ken Thompson had to find a bridge and an ease bridge between the computer world and what the users, an ease bridge, and then shell was the concept that he came up with. So why the name shell? It was called shell because when you say shell, okay, we all know what a shell is. A shell is the outer layer. It can be anything of a seed, anything. So it was an analogy of what of how the shell is. Okay, the analogy that this shell here is going to what become a bridge. Let me accept this person and meet. So it was the analogy that this shell here is going to become a bridge between you and what the computer or the operating system. Let me use it that way. So this shell here was the outer layer. So you don't need to directly have access to what the the operating system. Let's say this is it's called there is something called kernel too, like kernel C stuff anything. Yeah. Yes, and then the shell comes. So this shell here, okay, this shell here is what is covering or is the outer layer of the kernel, the operating system, so that you don't have to see the complexities of how everything is going, what is going on there, the algorithms. Yours is just what communicated to the what the shell, acting as a what a computer what operator in our time. Just give your tasks to it, give your commands to it, and it will take off everything. So that was a solution that brought up about showing what is required of us today is how if we are Ken Thompson and we are going to what find out how we will be able to what create a bridge between the user and what the operating system. So this is what all is about. Before I move on, please make sure that you write notes because I'll be giving the paradigm what to follow in order to be able to build your own simple show. Make sure you have your pen and your book. You are taking notes, everything I say that you think you need. And I'll come to that, how where we are going to start from in building our own show, right? So Ken Thompson came up with the idea of Shell in Bell Labs, and a lot of things happened after the 1970s. He introduced the shell. It was called SH. Okay, so let me just. So the shells. Okay. The short for it was, should I number it? Okay, one SH for sure. And then from his ideology, a lot of shells came into operation. Like people were just trying to make it as easy as possible. They were trying to also implement their own forms of shells. And then so we had something like the fish. Does anyone know of the fish? The friendly interactive shell. We have the bash. We have the Z. Is it ZSH? I forgot it, but there are a lot of shells. Okay. We have the KSH. Yes, all of these things were what were gotten or implemented from the idea of what a shell is. Okay, so in order for the user not to find difficulties in get like let's say in order for the user to be able to communicate with the computer, the operating system, okay, the shell served as what a bridge. But there is some misconception people have about shells, and if you take that into what into operation and the implementation, you might actually find it difficult to, because once you understand this misconception, shell becomes easier for you to build. Okay, I wish I had someone to guide me through these steps for me to be able to understand some of these things and then come up with my own show. Sadly, for some of us, we didn't have the chance, and it became the rest is history. so so please take advantage of this very moment. Don't take it for granted. Take advantage of it. If my partner and I had someone who would guide us step by step, do this and do this, we would have really been happy and then would have had it very easy. But sadly for us, we were not fortunate enough to have someone. So please take this thing very serious, as I don't want any of us to go through the problem of being deferred and everything. Okay. And also, I'm not going to provide what codes. I'm not going to provide with you with solutions. I'm just making the problem what simpler for you to solve. And when you are not able to cross an obstacle, it is my job to what help you cross that. So along the way, we are going to be coding things, but I'm not going to be feeding you with the codes that do this. And please, Kimber is very real, so let's take care of that. Let's take note of that. So the common one today is what? Is bash. The common one today is bash. Okay, that is the born again shell. That is what mostly. That is a very nice name. Born again shell. That is a common one. Who brought about bash? Um, Brian Force. Yes, in the 1980s, Brian Force wanted to make this SH right as free as possible and as yes, it's just like making an update to an app. Yes. So he brought about the born again show, which most of us use. I'll be sending us back to the terminal so that we practice and implement some things for you to understand something. But for now, I want you to understand these basic concepts. Be writing them down and you are good to go. So yes. So let's move on. So in the born again show, you've probably heard of Jet Bash. You've heard of a lot of things about the born again show. Most of us. So that is the history. That is everything about show. So in the computer we have the kernel, but you don't need to know about sorry. You don't need to know about the kernel now. For now, just understand the show. But know that the kernel is there, and the kernel is like okay. The kernel is like the heart. Okay, it is like the heart of the operating system. We don't need that yet. I don't want to feed you with unnecessary informations. Then we come to the shell. Okay, so where we are operating as software engineers is what? For now, is what the shell. This is where we are going to operate. So it is where we are going to what? Implement everything. So the kernel is like what? The heart of the operating system basically. So the shell acts like as a bridge, okay, for you to get access to all of these things in the computer. Okay, I'll explain that. Don't worry, because of time. Let's move on. So, should I go with some of the things the shell uses to, or let me just? So let's go on with the definition of shell. Where is my note? So in order for us to implement our own shell, Please, at this point, is anyone having any question? Is anyone lost? Any confusion? Is anyone having any question? Because you're about to delve deeper into it. Is anyone having any problem, misunderstanding, question, anything to say from what you've done so far?
Yeah, good afternoon.
Okay. Yeah. Hello. Do you have a question?
Yeah, I have a question. Lost that user. I do not fully understand.
Good. So I take that as a no. So let's move on. If you please, if you don't have any question, please mute your microphone. Yes. So this is how it works. The computer. Okay. So we have what? Should I say the operating system? Yes. It's the right term to use. And we have what? Shell. So yes, I know this is also a bridge between the shell and the operating system. I'll explain that. So even as the shell is serving as a bridge between you, the user, and the operating system, the shell also has what? Has a medium in which it uses to what? Contact the what? The operating system. Okay. So when we talk about operating system, we all know what an operating system is. We have Ubuntu, um, we have macOS, we have Linux. But one thing I want you to understand is shell is what? Shell. Though there are different types of shell which their operations may vary in different times, I would wish to implement that for you, but I don't have the other shells installed. I'm using Bash at the moment. I'm on a Linux environment. Not this. It's not even a shell. Let's continue. Shell is always shell. Okay, that's one of the misconceptions I want us to understand. That shell is always shell, but operating system what varies. What do I mean? When it comes to shell, okay, shell is not. Let me show you. Okay, so let me. This is my Ubuntu environment. Okay, let me log in. Can everyone see my screen from here? Can everyone see the virtual machine?
You are seeing it.
If you can't see, please let me know. Good. So
Very
I assume
clear.
you all can see. So this is as you can see clearly. This is what this is not shell. Okay, this is a terminal. Okay, one thing we mostly think is that this is shell. No, this is a terminal. And what does this terminal do? I'll come to that. The difference between a terminal and shell. That is one of the misconceptions. A shell is different from what a terminal. A shell is a program, as our sister said. Okay, it is a program with a bunch lines of codes. It's just like writing a program and do this with a particular task, and it's perform the codes. I probably think it's it's Canadian language. I don't know, but I think for sure they will need a low level language like C, and yes, because of the use of some system calls and everything. That is why we are learning what C, and then we are trying to implement it into building a simple shell. And that shell program contains codes. Okay, specific what codes to run whenever you what you open your terminal. So opening your terminal, let me try something. Yes, when you enter Bash, this is what happens. It's like, so opening your terminal, the terminal serves as what? An emulator. It's a screen to display what is happening in what? The shell. Okay, so before I come to that so let me let you understand that shell and what? Shell is what? Is different, is is different from what? Terminals. Shells and terminals are not the same thing. Also, shell is a program. Okay, so I can say this. Shell is a program. Let's continue. So, whenever you, the user, okay, opens your computer and you open this terminal, for instance, like this. Okay, this is your terminal. Whenever the programmer enters the terminal like this, this is what happens. The shell, okay, it serves as what? The interface for the operating system. Okay. The terminal is an emulator, making you see whatever that is going on, whatever you are doing. Okay. So this terminal is what's acting as a display for you to see what the shell is doing, or it's be able to, for you to see what you are trying to communicate with the shell program. Okay. So the terminal is what between you and what and shell. Okay. So it doesn't exceed shell. So the terminal that is not responsible for the execution of programs, its main purpose is for to display what is going on in the shell for you to see. It's like a screen. Like when you take a phone and you're able to see what you are doing on your phone. The screen is not responsible for what? For the operations and the functions or whatever the phone is doing. The screen is just serving as what? A display for you to be able to see what is going on. That is so the terminal is an emulator, okay, for you to have access to the shell. So let's start with some things like so I've talked about the fact that the most common shell use is the born again shell. Okay, so let's start with some basic things to note about shell. Most of our friends have said a lot of things. So let me just this writing is separate. Now I've not really gotten time to be doing it. So let's say simple shell. Okay, no, let me just say shell. So we have a shell, and this shell, okay, I will demonstrate it to you, but for now, try and understand. Okay, this shell, okay, is first of all, I like the analogy my sister used. So let me say it's a bridge, okay, between what? Between user and what? So far, what we've done so far is a bridge between the user and the what? The operating system. Okay, we can also say it is a program that is long. I can't write this. So you write it down on your notes. It is a program. It's a program that interprets. It interprets. So when you enter a command or if you enter anything, the shell interprets whatever that it has received from the terminal. It tries to interpret it. Okay, so we can say it's a program that interprets, okay, and executes commands. I'll come back to this again, don't worry. And executes commands. So that leads us to the question, what is a command? If you understand this, if you're able to understand what a command is, you are halfway done with your shell because most of it is about how you handle commands. So what is a command? Can anyone help us? What is a command? We are seeing a shell what executes a command. So what is a command? Very soon we'll go on to the PC. Don't worry. I will illustrate some things to you. We will go to the terminal. Anyone know what a command is? Hello, my software engineers, my programmers. Anyone knows what a command is? You don't have to mention names because I'm very good at that. I'll mention names. Yes, Bola. What is it? Bola, what is the command? Help us. Bola, we can't hear you. Is it from my side? Hello, Bola. Anyone help
Hello?
us? What a command is? Okay, Miriam, you can help us.
Two commands
Very
are
good. Please, if you are not answering, please mute your microphone. It's a bit disturbing. Please talk. What is a command?
Okay, I'll say command is a code that does a specific task for us.
Okay, it's a code that does what? A specific task, right?
Yes, or even a program or code.
Okay, so it's a code that does a specific task. Okay, Okay, so it's a code that has a specific task. We can also say that a command is what? Let me admit this person here. Bola, I raised my hand, but I'm not talking. Okay, I'm listening. Bola,
Can you hear me now?
yes, we can hear you now. We thought you actually ran
Okay.
for it.
I didn't run, sorry.
Okay,
So there are instructions that we give to our PC, but in this case, the instructions we type on the terminal to tell the computer to do something.
yes, instructions we tell our PC. Thank you very much. Thank you very much. So, do I have to admit? Okay, this admittance will be a problem. So, good. So, it's instructions we tell our PC. I like that. It's instructions, and it's a code that has a specific tag. That is also good. So, both of them are coming from different angles, but they are correct. So,
Hello,
this is
I hear me.
hello. I can hear you. You can talk, please.
Okay, they have taken the audio questions. Let me keep on.
Hello.
I hear me.
Yes, we can hear you. Please talk.
Okay, it's a command that computer understand.
A command that the computer understands. Let me just say command. It's a command, okay? So it's a command that the computer understands. Okay, that is good.
Yes.
So this is what's going on. Okay. First off, okay, let me just add the fact that you said it understands. Because you'll be dealing with that. I said very soon I will tell you the steps we are going to use. And this one also plays an important role. So this is what we are going to do. In this project, we are going to be what? In the place of what? A shell. If you are what? A shell, how would you interpret the request of users? If you were to be a shell, that's less if so you are taking the role of what, the computer operator in the 1950s. As a computer operator, when you are given tasks by a user to perform, what do you do with the tasks? That is when you find the answers to this question, you are halfway there. So let's start somewhere, let's end somewhere. So let me go into details to what they said. So we say a shell executes a command. So first of all, this is what a shell does. Okay, should I should I go to the terminal to explain what they've said? Okay, so this is what happens. A command is a code. It is a program. It is instructions. Good. And our brother used literally what a command is a command. If I tell you to go, you know the meaning of going. You know what it means to go, right? So before we be able to tell the computer for the computer to understand, there is languages the computer understand. That is why there is something called shell scripting. Okay, shell scripting is used for automation. I'll come to. I don't think we need that for now in the simple shell. No. So in order for the computer to understand something, you need to speak in a language it understands. Okay. Except this time you are what? You are trying to build an interpreter that will communicate with what? The computer directly and try to understand the languages the user try to give to it. So let's move on. So let's go. I said shell provides some features like what? Command. So let me write it again. So it has what? It forgive me for my pen. So it does command execution. I'll explain something to you now. It takes a command and it executes the command. Let me just go to the terminal to make it easier so that it doesn't look like we are just writing. So this is what happens, okay? Let me explain to you how the shell works. Whenever you enter ls, let me zoom in. Can everyone see from here? Let me try and zoom in. Yes. Whenever I enter a command like ls, okay, what is happening is that okay, shell is taking ls. Listen very well. There are some procedures shell follows and it does what it does. First of all, shell takes the command ls and it doesn't just take it and what it's a form of instruction. So ls is a command. Ls is not just you typing or it's not just an input. It's a set of instructions that instructs the operating system on what to do. Am I trying to? I don't know if I'm trying to make meaning to this. When you enter LS,
Yes.
LS is a set of instructions that the computer follows. It's a set of programs, instructions that the computer follows before what you get this display. So LS is a command, and we are saying that what Shaw is responsible for executing this command. Mind you, when we talk about execution, something comes into our head. What are we able to execute? What's happening now? So execution has to do with complete command execution. Execution has to do with what? We know how to execute bash files, right? Most of us know. Execution has to do with from the C, or you know that if you want to execute something, or let's say you want to execute a script, you first bring this, okay, and you bring this forward slash, and you enter the name of the program you've written. So let's say it can be anything. I wrote a program called CP. So I want you to understand that the command execution is what? Is what? Is the running of a program. So ls is what? Is a program in what? The computer. And this program, just like everything, so let me explain something to you before I move on to it. So let's say I built something. I don't know if I'll find it here. Let me run my background. No, let me use this. Let me zoom out a bit. No, I don't want to again. Please go back. So let's say, let me confirm something first. Sorry, guys. Yes, so we are good to go. So when what was I about to explain? So I have this part called CPS. Let me enter there. So if you remember very well, we wrote some codes, okay, and then we were asked to write a program that copies the content of one file to the other. That was the instructions. Okay, so we're asked to write a program that copies the content of what one file to the other. I want you to understand that the moment you're able to write a program that copies the content of one file to the other, it becomes what? A command. Let's move on. CD trial codes. So I have this here. It's called CP. Okay. So I wrote the program in a way that we all, I don't know, most of the for most of us who were able to do the file input and output, it becomes very easy for you to implement some of these things. So this was the idea we got from, it was one of our tasks. We were supposed to write a program that what copies the contents of one file together. And then I used CP. Now, the moment I do this, first of all, let me do something. Let me try and run something like this. It says no search file or directory. I want you to come to understanding. So there is no search file called SSH. So whenever you enter something like this and it tells you command not found, what it is trying to tell you is that there is no search file or program in the system called LSL for me to execute, because that is my work. I am sure what I do is that I take a command, I go and look for the program wherever it exists, and I execute it. So you are trying to tell me that LSL is a command, but in my program, LSL, there is no LSL in the operating system I am communicating with. Hey, operating system, do you have a program called LSL? The operating system is like, no, there is no such thing as LSL. Then it returns it back to you that there is no such file or directory, but it puts it in a way that the command LSL not found and gives you what it found. Okay, so let me explain it to you. Let me go a bit deeper. So this is what is happening. Imagine this. I have this file, okay, called CP, sorry, and I run CP. This is what it's telling me. It's telling me the usage. It's telling me how I'll use what? The CP command or the CP program. Because when I was writing it, I wrote it that it does not need to what run alone. You must give it a file where it is going to copy what the this thing. So I must give it the file where it is going to copy the contents from. I would I would want to illustrate how it works here, but for the sake of time, let me try and be fast. So that is what happens. So when you run ls, It is basically the execution of what a command. Now let me illustrate that to you. That is why when you run bin ls, am I correct? No, sorry, I'm wrong. When you run, can everyone see? Let me clear the screen. First of all, before that, let me try and accept this person. Okay, so no one actually. So let's get back to. So this is what is happening. So when you run bin ls, okay, it does the same thing as what ls. Forget the coloring for now. It's a matter of implementation. But I want you to understand that this is what happens. Okay. So what basically happens is that this this ls is a program, meaning that when you want to find a program, you can find it in the operating system. All you have to do is to find the path to it. You have to find where the program is. So let's find where ls is in our operating system. Let me go to home ls. Let me just cd into it. ls is in the user bin. Okay, so I think it's because I'm there. So let me just remove this from there. Is the user here? Yes. So let me remove this from there. Wow. Okay, so I'm trying to open into ls, but it's a program. So let me enter the bin directory. So when you list, okay, you list here, all these are what? Programs. Okay, that's what I want you to understand. So if you want to find what ls here, you are going to find ls here because it is a program in the operating system. So this is what happens. Let's find ls here. So this is ls as you guys, can you see the ls clearly? Let me zoom in a bit. Oh, so we have ls here. Oh, we found it now. We have ls here. Okay. So what happens when you enter ls is that the shell goes to the operating system and looks through the what? The executable files or the programs it can run. And when it finds ls, it executes. That is what we mean by what? The shell is what? It executes command. Okay, so let's say if you are here and we try to run ls. I've not tried it before, but let's try. There is no harm in trying. Yes, it does the same thing. It lists what them because you are running a program called what ls. So it's basically the same thing. That is what the shell does. Okay, so let me clear it and let me illustrate it again. Yes, so let me admit this person. We move on. Okay, so there is no one. Or is it like a glitch in my system or something? So let's see. Let's go back to our notes. So my program CP. So ALX is not asking us to write what the program ourselves. The program already exists. ls. If you are to search through, you'll find most of the commands, every command or every program that can be executed on it. If you are to search through, so in order for us to be sure of that, someone should give me another command that we can use to confirm this. Another command. Um,
MV move.
please come again.
MV move.
MV.
Like the move command.
So we know
Yes.
that this is a program that moves from one file from one path or destination to the other, or it basically renames another program. You can say that too. So it means that whenever you enter MV, okay, this is what happens. The shell being the bridge between you and the operating system goes into the operating system and says, hey, operating system, do you have any program called MV? Once it finds it, yes, then it's what? It executes it. That is basically what we mean by what shell is responsible for what command execution. So when we go through our codes, our files, let me list it. So we see the colors, list of executable commands or programs. We can find MV, right? So, there need to be somewhere here. Oh, so we have our MV here. Okay. So it goes through all this process, all these instructions. It goes through and until it finds the MV and it does what? It just executes that program. I don't think we are going to be able to execute it without having a file. I don't want to make any alterations to my program. So it does this. Yes, so missing file operand. So when I add a file, you're going to move the file. So, but the good thing about it, what makes this shell a simple shell is you are not dealing with the kernel. You don't have to do the programs in the operating system. Just deal with what? The shell that communicates with what? The operating system. The shell, you have to indicate the, so when the user enters something like this, okay, so first of all, let me show you the path where this is. First of all, if you want to find where this is, you go to your, is it home? No, root, sorry, root, cd into root, you ls, you go to user, there, usr, cd into user, you go there and then you go to your binary files. We all know what a binary file is, ones and zeros, executable files or programs. So let's seed into it, seed into bin. So yes, and you find them. So you are going to handle how shell is going to accept when a user enters this. You are going to make sure that your codes will run through will go to the operating system and ask and perform the particular task the user is asking. You are the computer operator. You have to work with your codes, right? Communicate with what? The computer, the operating system. Do you have any executable file called ls? And if it says no, what do you have to say? You have to tell the user that command not found. The file you are looking for was not found, but in order for them to understand easily, command not found. Okay, so let's not waste much time here. That is the first thing the shell does. So I will try and explain how it takes the command from the users. It takes it and it interprets it. How we are going to implement that. So for now, we understand what the command execution means. Okay, so this is what I want you to do. I want you to get time when you are free. Go through all these executable files. Okay, okay, that is obviously a waste of time because it's a lot. Some are not really necessary for now. We need to know much about. So let's forget about that for now. So I've been able to explain what the command execution means. What it does, input and output redirection. So please, before we move on, does everyone understand what the command execution means? Let me summarize everything there. Commands are what? They are basically binary files in the operating system. And the shell what? Communicates with what? They work hand in hand, goes to the operating system. Hey, operating system, do you have any program called ls? Do you have any program called mv? What the user sees as what? As a command. The reason why I call it a command is because it is telling the shell, go and do this for me. Go and ask the operating system whether I have access to these files, whether I can execute them. And it goes, do you have any binary, any executable file, any command called ls, mv, and a whole lot. I was about to mention cd, but it's not part of them. For now, I'll explain. And then I'll explain it later. We'll come to that. For now, understand this like ls, mv, the other commands. I don't know it's of the bat, but yes. And it goes, when it does not find, it prints an error to the screen saying what? Command not found. Okay, so how are you going to implement this? We'll move to that. So before we move on, please, any question concerning command execution, how shell executes commands? Is anyone having any problem or any question? Any question, any command? You can ask anything. What if you don't understand anything? If you want us to try anything, if you want us to do anything, you can ask. We are good to go. Okay, with that sense of no questions, let's move on. Which means everyone understands and no one is having any problem anyway. Is that right?
Yes.
Everyone understands everything so
Yes.
far.
Yes.
Hello?
Yes, we can move on.
Okay, sure. So let's move on. So Shell also does something. The second thing Shell does is okay. it takes it deals with input. Let me not miss anything, please. Okay, okay. So the second one, it deals with input and output redirection. Okay, or you can basically say input and output redirection. I think most of you already know what this is. If you don't file input and output, you know what input and output redirection is. When you talk about input and output redirection, we have commands like echo, sorry, or programs like executable programs like echo. Why is my this one messing up now? Sorry guys, let me get it
Yeah,
straight
so
because
I have a question.
I'm
So
recording this. So we have echo, we have cat. Okay, these are what these are some potential uses in input and output redirection. What does it mean? In your program, in your shell implementation, in your simple shell implementation, what you are supposed to do is whenever a user enters a scenario where a user enters a command like this, let me find my terminal here. So let me make it a bit small here so that everyone sees it. Let me go back to my projects. So whenever a user enters something like this, echo, okay, what is the shell supposed to do? We need to handle that. The shell is responsible for the input and output redirection. So in order for lessons, let me go to my trial codes. It's my trial codes here. CD, is it? No lessons. Yes. I use aliases that I mostly forget how or where they are explicit. So let's say if you enter something like this, okay, how is the shell going to communicate this to the operating system that this is what the user wants to do? If you were a shell, if you were the computer operator, how would you handle such scenarios? That is what it means by input and output redirection. You're able to, as the name says, you're able to input text. Okay, you're able to input command text anything into a file. Okay, so with the input and output, it brings us to something called the standard streams. You have to you would have to do with that later. Should I accept anyone? Yes, citizen. Any question? Any question? I'm about to delve deeper into the redirection. Any question?
okay, thank you. In this case of share, simple share, do we need to be
Can you please
putting
talk
it?
louder?
I hear me now. Hello.
Yes, please talk. I'm listening.
Okay. In the shell, in the simple shell, do we need all those commands to include on our terminal when writing code?
Okay, 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 okay. Good question. Good question. So let me answer citizen before we move on. The question is asking that do we need wait, let me make sure I get you right. Are you trying to show citizen is what you're asking? Let me go back into the CD user bin binary files. Are you trying to ask that are we going to write all these programs?
No, as in when the question they're giving us in our is, do we need all those code to be
Please ask come again. Please
I
does
said that
is anyone able to hear him? Then the person tries to amplify it for us. Citizen, please come again. I was hearing you, but you stopped.
okay. Hello, I hear me now.
Yes, talk.
I said that do we need all those code to be as in, to be putting it in our terminal? All those echo as in, do we need it in this case?
These files here, do you need it?
No. The as in the commands. Do
The
we need to
commands.
use it to in this? Yes, all these commands. Yes.
Let me see. I understand your question and answer. If I'm not able to answer it, then you prompt me. Okay. So what I think you're asking is that okay, all these commands like ls and echo, do you need to implement it in your code? So let me.
Yes.
Okay. So then it means there is a bit of so citizen. Please be with me. Okay, understand something. Okay, cd, all these commands, everything, every command, okay, every command here, it's in the operating system. It is not the work of shell to what? To deal with these files or these commands. The work of shell is to what? Is to take your input and find where these programs are and execute them in what? Wherever they are. So the work of shell is what? Command execution, but it is not responsible for the command as a program on its own. That is why it is called what? It's a bridge. It's a bridge that leads you to these commands or these programs, these executable programs. Okay, it is a bridge. So when you want to press ls, okay, whenever you enter ls, this is what happens. So shell serves as what? A computer operator. It goes. So let's say if shell is here, let's say shell comes to you, citizen, okay, and it when it comes to you, it asks, citizen, what do you want to do? And you say, I want to list the files in my current directory. So then shell then goes back to the operating system and it looks through the path of the operating system. A path is a direction. It looks through all the operating system and it goes, it searches, it searches, it searches. When it finds an executable file that is the same as what? ls, then it comes back to you and says that I found ls and this is what it does. Then it executes it for you to see that this is what ls did in the operating system. So shell itself is what? Is the betweener between you and the operating system. So the files shell has nothing to do with ls and cd. No, sorry, let me not mention cd now. I'll explain later why. mv. How come all of a sudden I've forgotten the commands? So all the commands, yes, basically all the commands. Okay.
Okay.
So shell goes to the.
RM.
Do you understand what I'm trying to say?
Yes, yes.
Yes, good. So you will not, what you need to, so if you are building the shell, what you need to be concerned about is how the shell is going to find what? These programs and give them to the what? The user. Okay. So you have to tell it that, so the command is basically you commanding what? Shell that go here and find this file here and execute it here for me. And it's take up that if only your codes. So one thing about this project is that knowing the right functions and system calls to use play a very important role, honestly, because some of these functions and system calls makes it easy for shell to be able to understand what you're trying to say. For the shell you are building, for the operating system to be able to understand what the shell is trying to say. So it's a matter of communication. Let's say we have two instances, okay. Let's say, let's use anyone. Let's say we have the president of France. Please, this is just for example's sake, please. Okay, so the president of France probably speaks French, and let's say he doesn't understand what? English. So what you need is you need an interpreter, or let's say no, there are two people trying to communicate with what? The what? The president of France. What happens is that one person is not able to speak French, and one person is able to speak French fluently. So this is what I understand. It's a matter of language. The one with the most what? The most comprehensive language, or the one who is able to speak the French fluently, is the one who is able to what? Get the attention of the president. Why? Because that is what he understands the most. So if you're handling commands, okay, it is the codes. We are all using one language, okay, we are all using C language. So we are all using one language to communicate with this president, but it is how you're able to construct your words, how articulate you are, that is able to make you what? Reach to that president for him to understand what you are trying to say. So two people may build two different shells with the same code, but you may notice that one can work faster than the other, or one produces a better result than the other. Okay, so it's a matter of how you're able to. So that's what I'm saying, that the functions and system calls and how you write your codes play an important role in this project. You need to make it in such a way that it is very easy for the operating system to understand what you're trying to say. I'll touch on that, some of the mistakes you make, like let's say trying to assume the command the user will everything. We don't do that. Okay, I'll come back to that. Because of time, I want to us to move as quick as possible. So thank you, citizen, for your question. It touches something. So let's say when a user enters a command like echo, let me go back to where I was. When a user enters a command like echo, how are you going to handle it? You need to take care of all of these things because when I enter echo, what should I even do it? Please, how does the echo command work? So let me see. Does it work? Yes. So when you enter something like echo and you say echo like print, my keyboard is not really close to me, so print this statement. So I'm not able to get it very well. I'm using my drawing board. So print this statement. Okay. What echo does is it prints the statement right below it. So it means that shell understands that this shell, not our shell we are about to implement yet, this shell understands that whenever the user brings the command echo, what I'm supposed to do is I'm supposed to what? Output the text on the screen for him to see what is on the screen. That is what the computer understands. And let me tell something. Thank you, citizen. So let's say in this explanation, okay, okay. So ls, let me open another terminal and let me use PowerShell, or let me use the same. Let me open a terminal and explain something to you. This terminal, okay. We have a command, the terminal called command. Okay. You realize that it's the same shell. Okay. That is able to serve as a communicator between us and the normal. I'm trying to explain something, but when you enter, let me use this. When you enter a command like ls, it says that it's not recognizable as a command. But when we enter the ls here, when we enter the ls here, we get a result. But when we enter it on what? This why is this thing becoming a problem now? When you enter it here, we are not able to what, get anything. What it's trying to tell us is that the problem is not with the shell, it's with the operating system. The shell went to the operating system, but they didn't find any ls program there. Because Windows is a different operating system from what? The Ubuntu or the Linux operating system. So they have different file names. So what is ls? The file name here, I think when you use dir, yes, sorry, it's list. They do the same thing, but they have different names. So it is a matter of what? The operating system. Okay. So shell has nothing to do with the files. It will just do what you want it to do. It will go to the operating system. It will look for ls. If it does not find it, it will tell you that yes, ls is not recognizable. I didn't find any ls. Okay. But when you say dir here, it will list it. But when you use, let me try, I've not tried it before. When you use dir here, okay, that's the same thing. It does the same thing. That's very nice. So it's good to try. It's good to try. So it's a matter of what the operating system is, meaning that the dir resource is being understood by the operating system. Let's move on so we don't waste time. So with our echo, okay, so you have to handle that whenever I enter something like echo. What do you want the shell to do? You have to tell the command everything. I'll explain what it means. We have interactive mode and non-interactive mode. I'll explain all of these things along the path and the way. So Shaw is responsible for this. Let's say we have a file. Let's create a file right now. What do we use to create a file? Touch. No caps, sorry. Let me make this bigger. Let me clear here. So let's say let's create a file called tst, right? Test.ts. Let's give it extension tst to mean I will put test in it. So, and then we want to echo something into it. We both know. We all know how to echo into something, right? Now we say we want to echo E, or let's say print this. Now, you're able to bring this sign. This plays an important role in the redirection, the input and output. We are trying to say that put this test into what? Into the file called what? Test.txt. Yes, that is what it means. And it does that. So how is your shell going to handle some of these things? How is it going to redirect my text, whether to output, that is a standard output, standard input, standard error, how it will print into a file, how it will print into, and it's very easy when you know the right commands to use. Okay, so for the sake of, let's use car to confirm what is in TST. For the sake, if it really worked. So why is this thing happening to me now? TST. Oh, print this. So it actually did the work for us. Okay, so it was able to do it. So you are going to handle all of these things, but don't worry. So that is one thing about shell 2, handling input and output. Uh-oh, I think the person. So let's move on. So the third thing we want to know is what? So we have input and output redirection. So the third thing we want to know is variable handling. Sorry. If time permits, we'll go through all of these things. But what's the time? Let me try and be fast. Variable handling. We also have control. Please, when you get time, when try and go through these things. Time is not on our side. Control structures, variable handling. Please write them down. It will play a very important role in what in your show, depending on what is required of us. When you get time, go through this. So these are some of the basic things that, or the basic features or purposes of the show. Okay, they are the features of show. These are like four. So I think these are what we will need. For now, these are what we need in building our simple show. So take note of it. Let's move on to the next section. Before we move on, is anyone having any question? Any question? Are you confused somewhere? Do you want me to clarify something for you? So I assume that there are no questions and everyone is with us. Is everyone okay? No one is confused. Everyone understands everything. Good. So now let's use this to go through the resources ALX give us. Not go through as in go through, but this is where to start from. How would you start? So how should I call this? Someone should give me no. Let me say okay. So where to start? Is anyone trying to join or someone has a question? Where to start? In building a simple show. Where to start? Yes, citizen. Citizen, please, you have a question.
No, go on. This is where I'm testing on hearing
I should go
where
on.
to
Okay.
start.
Yes. So where to start in the implementation of our own simple show? Where to start? Good. So this is how I've taken time to write down and break it to simpler for you to understand. But um, please, this section is recorded. If you don't understand anything, because you need to before you start where to start, you need to understand some of these things, especially if you're new to what the simple shell. So I think I tried to get a YouTube channel for it. Yes, I'll share the YouTube link in the I'll share the YouTube link in the how do we say in the group. Yes, so that you can revisit it and be able to come back to it. Let me leave it in the chat. See. So I'll share the link. So this is how guys, can you please excuse me for a minute? Okay. Can you please give me like 2 minutes? Okay. Sorry, I'm coming. Okay. Sorry about that.